Hey guys, welcome back. Well, I was out doing some collimation with the SCT, and while I have usually used the defocus star method, I thought I'd give the Tri-Bahtinov method a try and some software that I found online. So let's get started. Collimating an SCT is not fun, but it is one of the tasks that we have to do for the privilege, if you will, of owning an SCT. Now, a nice thing to do with a laser collimation technique is you can do it during the day, which is great. The downside of the laser collimation method is that it does cost some serious dollars, and you have to remove your camera from the imaging train, which I don't necessarily want to do, especially if I'm in the middle of a project. Now, if you happen to be blessed with a full moon, then you might as well be doing the work in the daylight. Because now you can resort to the traditional methods of trying to fix a defocused star, such as this one over here, or you can use the method that we'll look at today with the Tri-Bahtinov mask. And if you haven't seen this already, there is a SkyCal focus and collimation tool that was developed by Dowd that gives us a pretty good numerical assessment of how good our focus is for our particular imaging setup, the focal length, the aperture, and the pixels in our imaging camera. And hey, I'm up for anything that takes some of the guesswork out of collimation. Just as a review, let's take a look at the defocus star method. There are plenty of videos out there, so we're not going to look at this in detail. But the idea is that you want the central obstruction, your secondary mirror, the shadow, which is that dark circle here, to be in the center of the aperture, the fully lit aperture circle. And then you can hold your hand in front of the aperture during a live session and see where the screw is that's closest to the point of closest approach between the two circles, and then you can make adjustments either by loosening two screws and tightening one, or loosening one and tightening two, to iteratively bring that central obstruction shadow back into the center of the view here. Before we take a look at collimation with the Tri-Bahtinov mask, I want to introduce this software to you. Some of you have probably seen it. I'm sure it's been out a while. It's just new to me. It's the SkyCal focus and collimation tool that was developed by Dowd based on the algorithm that was developed by Niels Nordhook when he wrote the Bahtinov grabber software that some of you used. I certainly used it. I liked it. It was a very convenient piece of software for achieving numerically accurate focus with the Bahtinov mask. So that was a great piece of software, and Chris has done us a great service here by extending and updating that software so that it now works not only with the defocus star and the traditional Bahtinov mask, but it also works now with the Tri-Bahtinov mask. Let's go to the web, and I'll show you where you can find this to download it yourself if you don't already have it. Type in Bahtinov collimator here to the Google search bar and hit return. That's what I've done here. And you can scroll down until you get to the GitHub page for Chris's Pally Knight's name, which is insert name here, one. And you can click on that and it'll take you to the GitHub page. Come over here to the releases, and this is where you can find the setup software. Just download that and run it, and then that will set the tool up on your computer. Now, it also has a manual of sorts. The manual, frankly, is not that great, but then this isn't that complicated of a thing to use, so I can understand that. There's a help.pdf file here. You download that as well just to have it handy. Now, when you run this with a defocus star, this is the image that I was getting. So here's what I came up with my defocus star method of collimating. And as you can see over here, in a live view, this offset is continually changing, and it's apparently telling you where the thickest part is, the biggest distance between the edge of the center obstruction and the outer edge of the aperture ring. And this arrow will be dancing around because of seeing effects. The numbers will be changing, but it is giving a good indication of where you need to make a change to improve the collimation. It's along this axis. And once again, you can play the game of sticking your hand up in front of the aperture and figuring out where you block the view and the arrow, and then that will be the set of screws that you need to alternately loosening two, tightening one, or loosening one, tightening two kind of thing. I found this tool to be extremely easy to use. So thanks to Chris for bringing Bahtinov Grabber back to life and giving it new capabilities in handling the defocus star and the Tri-Bahtinov mask. You've all seen Bahtinov mask, so this isn't nothing earth-shattering here. The traditional Bahtinov mask has lines going one way and two other sets of lines that come in at an angle, and that produces that familiar diffraction pattern that we see when we use the Bahtinov mask. Now, in a Tri-Bahtinov mask, you've got entire circular area divided up into three sections, three Bahtinov masks. For example, this section over here has the straight lines here and then the two angled lines coming in. This section over here has the straight lines here, the two angled lines coming in, and this section up here has the straight lines with the two lines coming in. And of course, when you put this mask over the aperture, this is what you get. You get three sets of the traditional diffraction spikes. If you cover up two of those three little slices and just leave you with effectively one Bahtinov mask, but off to one side on the aperture, then this is what you get. You get back to the original Bahtinov mask diffraction spike pattern. We can now get the benefit of the numerical focus assessment that Bahtinov Grabber gave us for a traditional Bahtinov mask, but now we can get that same numerical feedback with a Tri-Bahtinov mask. Let's go take a look at how to use the SkyCal focus and collimation tool. So here I've got a traditional Bahtinov mask in front of the aperture, and we're seeing the familiar diffraction spike. So let's call up the SkyCal focus and collimation tool. It comes up. The first thing you want to do is to go into settings and set up your aperture focal length and pixel size for your particular scope. In my case, I've got a 235 millimeter aperture. I've got a focal length of 2315 and my pixel size is 4.63 micrometers, and then that calculates the critical focus zone over here. You can also turn on voice guidance if you want to use that. But now we're ready to make actual numerical assessments of our focus for our particular setup using the numbers that we've typed in. And now we need to select a star. We're already in the Bahtinov mode. If we were going to use the defocus star method, we would do that. But we're going to be using the Bahtinov mask. And as you can see, it's a traditional Bahtinov mask. So I just need to select the star and we'll go to the center and pull out enough to capture the diffraction spikes. And you can see here it's giving me a grade of minus 0.8 pixels up here. And it's telling me that I am, in fact, inside the critical focus. Now, in the real world, when you're out using a live view, this image is changing all the time and this number is dancing around a bit. Not wildly, but a little bit. Now let's go over and take a look at what a Tri-Bahtinov image looks like. So here we have the Tri-Bahtinov image. So we have 1, 2, 3 separate sets of diffraction spikes for each of the three zones of a Tri-Bahtinov mask. And now we can bring up the collimation tool again. And once again, the settings will have been saved from the last time we set them, so we don't have to adjust that. The nice thing here is, again, we're set to Bahtinov mask. We'll select the star and pull out enough. And now you can see that we have three different grades now for our Bahtinov mask. In one case, it's telling me that two of these, the green and the blue, are within the critical focus zone, but the red is not. And this is where if you have a live view, you would hold your hand up in front of the aperture and figure out where that image actually is. Now, something else appears here while we do this. When we have it in the Tri-Bahtinov mask mode, we have an adjust assistant here. And if we call that up, you can see that we get the three screws that we have in our secondary mirror. And perhaps we can rotate this around once we decide with our hand which one is which. And as we're looking at the three screws standing in front of the aperture with a screwdriver, we can maybe arrange this so that it looks like it does to us, and then we can see which number is which. Now, the question that I have, I still don't know yet. I need to practice with this a little bit more, but does a positive error mean that I should tighten the screw and loosen these two screws, or loosen the screw and tighten these two screws? So that's something I need to work on. It seems like there's a configuration setting over here so you can reverse the direction. Once you figure out what it is that you need to do, you can make these adjustments, and presumably it will keep those settings and that configuration the next time if you save the configuration. Let's review briefly the workflow for using the Tri-Bahtinov mask for collimation. Obviously, first thing you want to do is slew and center on a bright star. Try to get as good a focus as you possibly can. And then take a look at those divisions that we were looking at in the Tri-Bahtinov mask earlier, the pairing of a straight line and then one cell with the two angled lines, so that this is an effective slice that produces a Bahtinov diffraction spike pattern. Then center that slice on the collimation tool. That way we know that if we're out of focus here, we know that we want to be making adjustments on these screws here. For example, I could loosen this screw and tighten these two, or loosen these two screws and tighten this one. Then we can start Imaging Loop and the SkyCal software, and then you'll start getting the continuous readout for each of the three diffraction spike patterns. Now, if you have something that looks like this, what you'd probably want to do is to look at the maximum 0.9 error, the minimum minus 0.5 error here, and say, well, what I'm going to do is get focus on this center one here, and then you can move your focuser to try to drive this as close to a score of 0 as you can, just looking at the green number here, the 0.7. And then that will drag this one down to about 0.2, and it'll drag this one down to a negative 1.2, roughly speaking. You'll start your initial collimation effort by trying to drive down the error that we see here until we get it close to 0. Now, you may not end up in the end with all zeros everywhere because it may still be just slightly out of focus, but that's okay. Just try to get down making these 1/8 of a turn adjustments, either loosening or alternately loosening 2 and tightening 1, or loosening 1 and tightening 2, and you want to try to get these errors to be the same number. It may or may not be 0 in the end. It could be 0.2, for example, for all three of them. That's fine. All that means is you just need to make one little focus adjustment, and you'll be perfectly in focus for all three of the Bahtinov spike patterns. And then that means your mirror is centered well with respect to the main mirror, and you have good collimation. The one thing I still need to determine is, what does a plus error mean? Does it mean that I need to adjust that screw with a clockwise turn or a counterclockwise turn? So let's take a look at the video I recorded the last time I was out doing the collimation. Okay, so I'm in kind of a 1 second loop here where Nina is continuing to take 1 second exposures and just cycling through those, not saving any of these. You can see we have the Tri-Bahtinov mask in place, and now I'm selecting a region to identify the star. And oops, this sometimes happened. Maybe I didn't grab enough of the diffraction spikes. That's fine. Just go back and start it over again and select the star and make a bigger circle so that you get more of the diffraction spikes, and then everything comes up fine. Now, if you look at this, all three of these areas are telling me this is just after completing the defocus star collimation. But you can see these numbers change a little bit, but I'm just on the edge of having good focus in the critical focus zone for all three of the zones. I'll lose a little bit on that red one. It still needs some adjustment. By and large, I'm pretty happy with the focus I got. It's just on the edge, and I decided to live with this. So after doing the defocus star method, which turned out to be pretty good, as you can see in that video, I'm still a little out of collimation, and I think there's some reasonable changes that I can make to the screws to improve the collimation a bit further. And with that numerical feedback from the SkyCal focus and collimation tool, I think that should be a lot easier than it has been in the past. One thing you want to do at the end of collimation is to make sure you end up with all the screws being relatively tight. I'm not talking about taking a torque wrench to the thing, but just make sure that they're tight. You don't have one that's loose, because then it won't hold collimation. A full moon is good for only two things. One, taking a picture of the full moon, or two, taking care of some tasks that we have to do. Maybe you're trying to learn a new piece of equipment or get the new piece of equipment up and running. You need to calibrate some things with your setup. In my case, SCT collimation is one of those great things you can do during a full moon. Now, the traditional collimation approach relies on the defocus star and centering the central obstruction circle, the shadow, within the aperture circle. I have to say, given my results here, it works pretty well, even if you're just judging by eye whether or not that central shadow